Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The starting material is 2-phenyl 1,3-dioxylane, which is a cyclic acetal formed from benzaldehyde, PHCHO, and ethylene glycol, HOT to CH2O. The reaction shown is the hydrolysis, deprotection, of this acetal back to the parent aldehyde and diol. Moving on to the next step. The starting material is a cyclic acetal. Acetals are stable under basic and neutral conditions but are readily hydrolyzed under acidic aqueous conditions. Moving on to the next step. Under acidic conditions, H2SO4 catalyst, with water and heat, the acetal undergoes acid-catalyzed hydrolysis. A lone pair on one of the ring oxygens is protonated, facilitating CO bond cleavage to form an oxocarbenium ion intermediate. Water then attacks this intermediate, and after proton transfers, the acetal is converted back to the aldehyde, benzaldehyde, and the diol, ethylene glycol. And for the final step, H2O, H2SO4, acid catalyst, and heat provide the acidic aqueous conditions necessary for acetal hydrolysis. This is the standard method for deprotecting an acetal to regenerate the carbonyl compound. A. Lyl4 followed by H2O. Lyl4 is a strong reducing agent. It would reduce the acetal but does not hydrolyze it back to the aldehyde. It would give an alcohol product instead. C. H2O. Now H. Heat. Acetals are stable under basic conditions. Base-catalyzed hydrolysis of acetals does not occur readily because there is no mechanism to protonate and activate the CO bond under basic conditions. D. PCC. CH2Cl2. PCC is an oxidizing agent used to oxidize primary alcohols to aldehydes or secondary alcohols to ketones. It does not hydrolyze acetals. Therefore, the correct answer is B. Therefore, the correct answer is option B.